Welcome to today's webcast, Cashing In with Connection-Oriented Ethernet. I'm Mike Roebuck, Senior Editor with CED. Today's webcast is sponsored by Fujitsu and hosted by CED. Got just a couple of quick programming notes before we get underway here. There's a button to make the presentation screen larger. You might want to go ahead and do that. Also, you can download a PDF version of the webcast. And make sure you ask questions throughout. We'll answer those near the end of our hour, but please submit your questions as we go along. And lastly, the webcast will be archived on CED's website probably sometime tomorrow afternoon. So we're going to get underway here. First up, we have Bill Beasley from Fujitsu speaking, and he's going to give us an overview of COE, including market drivers and different implementations. And then we're going to close with Stuart Jameson from Cable One, and Stuart is going to give us the cable operator's perspective, why Cable One chose COE, and go over some of their commercial fiber services. So with that, I'm going to hand it off to you, Bill.
Thanks, Mark. So as Mark said, I'm with Fujitsu. I'm in our strategy group for our packet optical networking products. Today I'm going to be talking specifically about connection-oriented Ethernet. Take a little different approach. I'm probably going to talk less about the technology itself, but dive into more about applications and why connection-oriented Ethernet is important to the MSOs and the MSO community. Focusing on market drivers, where your businesses are going, what customers you're trying to reach. I'll talk a little bit about the different implementations of carrier Ethernet. I'll run through some COE FAQs, sort of some things that people ask about it, and kind of touch on those. Run over the 6 attributes of COE, and then finally I'll close up with a couple of application examples that could fit within the MSO networks. When you're talking about the MSO networks, one of the things that's important to realize, it's really interesting, the MSO's plant, that is the HFC plant that's been built out over the past few decades, passes quite a bit of business opportunities. I saw one example where somewhere along the lines of 80% of small to medium businesses are within the reach of MSO plant nationwide, yet the MSO community only targets about 4% of that successfully today. So clearly there's some opportunity for business services, and HFC is a great way to do it. However, there are some market segments that are really difficult to serve with HFC. We see those market segments here on this slide. There are customers that are highly lucrative and asking for your services, and they're in the space. The carriers, the cellular providers, and other carriers are asking for high bandwidth, high availability services from you. The healthcare industry is really interested in getting high bandwidth Ethernet services as they start to increase the movement of their medical imaging and other data among their sites. Government, of course, has always been interested in linking up and getting high bandwidth services. And then the financial industry is another place where the MSOs can serve today. But it's very difficult to do these with hybrid fiber coax HFC because they're wanting more than the HFC network can provide. QoS reliability, the amount of bandwidth we can do with DOCSIS 3 today, they're very difficult to sustain what these customers are asking for using an HFC network. Operationally, it's tough. Technically you can do T1s to a cell site using a cable modem and an IAB, but the carriers aren't generally going to be willing to accept that because those T1s don't look and feel like what they're used to in terms of latency, jitter, bit error rates. So you end up with people complaining about the service even though it's working fine, and then you run yourself silly operationally trying to meet this. The other place you're looking for, especially in the carriers and the government, they're looking for an elegant mechanism to take their existing TDM, that is the T1 networks that they have today, and migrate them to Ethernet. We're seeing LTE evolution becoming very aggressive from the carriers. Most of them are having massive LTE build-outs. If you haven't already seen them, you will see them soon, and they'll be asking for Ethernet services. But they also want a mechanism to go ahead and make a nice transition with their existing TDM so they don't have to forklift everything they have in place. They can sort of migrate into it gradually. So let's look at the implementations of carrier Ethernet. Since Ethernet seems to be a great way to provide services to these market segments, I think it's important to talk about sort of the two different types of Ethernet and what we may think is Ethernet and what we're talking about as connection-oriented Ethernet. Of course, there's the COE, connectionless Ethernet, and then COE. So when most people think of Ethernet, they're thinking about local area networks. These are referred to technically and heretofore in this presentation as connectionless, or CLE. You usually have a single user per Ethernet interface. It's a shared infrastructure, and it's generally what we see in network inside a building. You don't see these things going beyond the campus very often at flat Ethernet networks. But CLE is also used in carrier networks. You can subscriber sites connected to an Ethernet uni. You get multiple users per Ethernet interface, and that networks across a wide area. This could be Ethernet mapped over SONET or something similar like that. There are some challenges, though, with connectionless Ethernet, and many of us have lived through these and lived through this pain. The first one is it's non-deterministic, and in terms of your ability to manage QoS and performance, it's very difficult because of spanning tree. What we all know and love, a spanning tree doesn't always quite work like we want to. And it's really, I say here difficult, but I almost like to say it's nearly impossible to traffic engineer variable traffic paths in a CLE, a connectionless network. It's also difficult to guarantee bandwidth. You got multiple ingress and egress points in your network, and anytime you want to do oversubscribed bandwidth in a connectionless environment, it's going to have an impact to your committed bandwidth. So again, traffic shaping becomes a bit of a nightmare, and it's just problematic. It's also really difficult to provide high network availability. I can remember about in the late 90s, I built an Ethernet network in downtown Oklahoma City, and one of the biggest problems we had with providing service in that network was anytime we had spanning tree, the reconvergence time was just, well, way too long. You can't do end-to-end service and protect it in a way that carriers and government and healthcare and your customers that are asking for high reliability are going to demand. And when you have that network event, they don't want to hear excuses about why spanning tree caused the problem. So let's look at connection-oriented Ethernet. The nice thing about COE is it's sort of the best of both worlds. Ethernet's inexpensive. It's sort of a beautiful thing in that, in terms of your ability to take bandwidth and reuse it and that kind of stuff, it's really great. You get layer 2 aggregation, you get your statistical multiplexing down to connectionless Ethernet, you get flexible bandwidth, it's cost effective, and like SONET, it's deterministic. You can have QoS, you can do bandwidth reservations, it's highly available, highly reliable, and it provides a higher level of security than connectionless Ethernet does. So it's sort of the best of both worlds. It's kind of getting your cake and eating it too. So let's look at some attributes of COE. If you look at the drawing, on the left-hand side we see that in connection-oriented Ethernet we can define explicit data paths. We can say we want our traffic to go this way. We want to control it. We want to control performance and make sure it's consistent. In connectionless Ethernet, because of the way spanning tree works, the data path is implicit, and we really don't know which way the traffic's going to flow at any given moment. It could take any of these routes at any time. The other thing we can do with connection-oriented Ethernet is we can reserve bandwidth. And we can do this per EDC, we can do it per tunnel, and we can support oversubscription. So we have deterministic performance on a per flow in connection-oriented Ethernet, whereas, as we know in connectionless Ethernet, the performance is statistical. It's aggregated bandwidth. So it's much more difficult to take care of bandwidth reservations and do guaranteed quality of service to your customer. So, why connection-oriented Ethernet? Well, as we've already said, it makes Ethernet more like SONET. And any of us that have been in the carrier business for a long time, or any period of time, know that SONET dominates metro networks today. It's what most people are used to, but it's not really as sufficient to carry Ethernet services. The network operations and procedures in COE are very similar to SONET. So if you've got SONET heads in your staff, you got people that are used to SONET and managing SONET, they'll get it. They'll understand what's going on here. So the transition for those trained personnel is much smoother to COE than it is to other technologies that work in other layers. It's also highly scalable. It meets your large-scale metro connectivity and aggregation requirements. You can take COE, you can scale it up to gigabits of bandwidth. You can manage large amounts of bandwidth to customers and meet customer demands. And it's supported over any layer 1 technology. So if you have SONET or PDH networks today, most of the MSOs aren't going to have OTN networks, but if you have WDM, SONET, that kind of stuff, you can do COE on top of that. And of course, you can do it over fiber as a native Ethernet service. It's ideal for metro Ethernet aggregation for service edge networks. So if you're bringing in internet, video, telephony, storage, cloud service, MPLS core networks, COE is ideal for aggregating those and handing them off to your edge. It's also ideal for mobile broadband backhaul networks. Ethernet is getting in high demand for cell sites, cell providers, and COE is a very efficient and operationally simple way to deliver that. And then, of course, commercial business Ethernet services to your medium to large businesses. Those customers that are demanding high availability, high bandwidth, high reliability, and high security. COE is really their best bet for that. It's designed to mimic SONET, so it makes your Ethernet point-to-point, just like a SONET circuit. Your Ethernet paths are provisioned across your network instead of being dynamically calculated, just like SONET. It eliminates Ethernet control plane and other layer 2 control protocols. It's much simpler. It's much easier to do. It's just like SONET. Gives you your 50 millisecond path protection, again, just like SONET. Gives you fault management, just like your DS1 loopback circuits. And you can guarantee bandwidth throughout your network, just like your CAN with SONET STSs. Again, like we said before, COE is sort of the best of both worlds in terms of performance and cost. So, again, what is COE? Just so you know, it's an industry term. It defines the point-to-point implementation of carrier Ethernet. It's been tracked for the past few years by analysts. COE has been around for about 10 years. It's not a relatively new player. It's been around. It's got some time on it. And the difference is that COE is a high-performance implementation of that carrier Ethernet, the connectionless Ethernet we looked at. It is standardized. Uses MEF, IEEE, IETF, insert other acronym here. And then it's got some value-added enhancements where the standards aren't yet up to speed. And you can use Ethernet or MPLS to do it. So let's look at the different approaches to connection-oriented Ethernet. And this is probably where you are thinking right now. So one of the popular ways to do Ethernet now is with an MPLS-centric core. Okay, you got your Ethernet, static, it's MPLS. This is optimal for multi-service transport. So if you're trying to do voice, video, and data in there, MPLS is a great way to do it, and a lot of people are. But it has 3 OAM layers. So when you guys start trying to do SOAM stuff and display that to your customer, it's going to be a little more complex. And it's less optimal for Ethernet service delivery and transport. So again, it's not as optimal as Ethernet. It's under development in terms of standards. The new standards are being developed now, augmenting MPLS. The Ethernet COE, though, is 1 OAM layer. It's much more simple to provision and then do the service OAM on. And ideally, again, a good old friend of mine always said, there's nothing better for doing Ethernet than Ethernet. and COE is optimal for doing Ethernet services, and it is standardized now. So again, the point we're trying to make here is Ethernet-centric COE is optimized for Ethernet and IP service transport, and where your MPLS core is optimal for multi-service transport. So if you want to do Ethernet, COE is a great way to do that. This is the COE ecosystem I talked about. We were talking about the 6 attributes of COE. Just touching on this quickly, it's standardized. It's MEF, E-line, and E-access standards exist today. It's scalable, allows for statistical multiplexing. It's highly reliable, highly available. You got 50 millisecond EVC protections, and your unis and ENI are protected as well. It has deterministic QoS, so you got low packet latency and loss. Your carriers will love that. They want to see low packet latency and loss on their Ethernet services to their cell sites. You can do bandwidth resource reservation, and then you can do leak fault management, EVC fault management, and of course performance monitoring, because very simply because you only have one OEM layer to deal with. You don't have to muck around in layer 3. And then for security, there's no bridging. So in terms of if you guys are familiar with MAC layer denial of service attacks on Ethernet networks, those are mitigated here because we don't bridge the networks together. And then it's completely layer 2. So IP vulnerabilities that exist in layer 3 aren't able to get into this network and cause you problems either. So that increases your security level and reliability. So again, COE doesn't use MAC address learning or flooding like connectionless Ethernet. Okay, so we can't do MAC address spoofing on your network elements. Somebody can't come in and try and fool your network into doing what you want. It's immune to the MAC address table overflows, denial of service attacks. It doesn't use layer 2 control protocols like spanning tree, so the protocol-based vulnerabilities are mitigated. It doesn't use IP protocols. It doesn't get into layer 3, so it's immune to those IP attacks. And then it uses few protocols. Again, in terms of security, the simpler things are, generally the easier they are to secure. So it's a simple equation. Fewer protocols, less network security vulnerabilities. So your security is comparable to layer 1, like Ethernet over SONET, but you don't have to deal with the SONET bandwidth inefficiencies. So again, back to the statement we made earlier, it's best of both worlds. Okay, so hopefully at this point I've convinced all of you that COE is great and you're interested and want to see what we can do with it. So let's get some network drawings here. So for those of you doing commercial business Ethernet services to hospitals, banks, government entities, you can do these retail Ethernet services very easy with a packet optical network using COE. You can get COE between your end users. You can go COE between your IP service networks at the edge. You can do site-to-site services with COE between the end users. You can do wholesale access as well, so you can hand off to other retail service providers and partners. So if you're trying to do off-net services and partner up with somebody else to reach customers that are outside of your footprint, you can do that. Of course, the packet optical network platforms from Fujitsu is FlashWave, and it gives you the ability to deliver retail and wholesale Ethernet services, again, with SONET-like reliability and security. Let's look at mobile backhaul. I touched on that earlier, saying you guys are going to be, if you haven't been hit up already, you are going to be hit up by cell providers asking for your ability to deliver services to their cell sites, and this is a great business to be in. The nice thing about COE is it gives you a SONET to Ethernet transition. So if we look at the left here, we have your SONET Ethernet over SONET mapping into your existing SONET networks. We can layer in TDM and COE in the middle with our packet optical network products. And then finally, to the right, you see a service transition over time to a more COE-centric network. The nice thing is that with COE, you have the ability to go ahead and migrate your networks gradually towards SONET and do like implementations and then future-proof your networks for the time when customers are going to be asking for all Ethernet services from you only. So wrapping up here, so COE is a high-performance implementation of carrier Ethernet. again, it's the best of both worlds. It gives you the flexibility and scalability of Ethernet with the performance, reliability, and security of SONET. It's all good. Supports most popular Ethernet services and is ideal for delivering high bandwidth, highly reliable, highly secure applications to the business customers in your footprint. Those of you who want to find out more information on our products, of course, you can go to us.fujitsu.com/telecom. And with that, I'm going to hand it over to Stuart Jameson with Cable One.
Thank you, Bill. My name is Stuart Jameson. I work with Cable One. I am a network engineer on the commercial side of the house. I have been building and designing fiber to the X networks for Cable One for the last 5 years, delivering services to businesses, fiber to the home, cell towers, anything fiber related. Cable One is a cable operator serving small to mid-sized communities. We approximately have about 647,000 customers within 19 states. Our average system size is about 15 to 20,000 subscribers per market. We provide cable television, telephone, and internet service. We're a wholly owned subsidiary of the Washington Post Company, and we are corporate headquartered in Phoenix, Arizona. So some of the services that we deliver today, everything we deliver today is Ethernet only. We do point-to-point, multi-point to multi-point, IP services for internet, last mile, intra and inter-network transport. Being in these small markets, it's very challenging getting to some of these customers and delivering them when we don't have the other end. So usually we have to partner with other carriers and other businesses in order to get that to happen. But we do very well with large entities like schools and banks. But it's pretty similar to what everyone else is doing out there. So we chose Ethernet services because it scales very efficiently. From a CapEx standpoint, it's very cost effective, delivers more bandwidth quicker and easier. Ethernet has helped us keep a competitive edge as bandwidth costs continue to drop. We're continually reevaluating our sales team, our structure, how we're meeting our objectives and our ROI models, and making sure that everything is very streamlined. In that last 6 years of doing that, we've come a tremendous way in delivering the Ethernet services, and we've seen it really evolve to become something quite amazing. So all of our metro services that we deliver today are all based off of Q&Q, which is currently connectionless. The connection-oriented Ethernet is more cost-effective than MPLS to the edge. Using MPLS requires a higher-end type of equipment. And being a small cable operator, you don't really know who you're going to be able to get when you go out and start delivering these services. So when you start delivering MPLS and you invest, hundreds of thousands of dollars in the equipment to go out there and do it, you may only end up getting, 1 or 2 fiber customers in a given market. So that's pretty much why we've stayed away from that for the time being and just stuck with a Q&Q type solution, connectionless. But that introduces its own problems. So our current fiber customers that we're seeing that are taking our services, critical public health services, hospitals, medical centers, 911 call centers, cell towers, schools, state, local government, banks, college, universities, television, radio, and business customers. These are business customers that have more than one T1 line or more than 20 people working at a site. The interesting thing about that is that they don't, if they're already on DSL or using a DOCSIS-based cable modem, they're probably not going to want to move to a fiber service. They're pretty comfortable with where they're at and the service that they're getting from that. So some of the challenges that we have by delivering a connectionless based service with Q&Q, some of the issues we have is that when you start doing some of these larger schools like colleges and schools and government buildings, it becomes very challenging because you have to start managing it from a MAC level. It's very easily adding all these customers, you can overrun the MAC table on the equipment. So you have to pay attention to how your equipment is actually growing, and it's not uncommon to see 14,000 MAC addresses on your network. Everything's growing. You know, you got your printers, you got your computers, you got TVs now that have Ethernet connections on them, phones, all this stuff. It all becomes part of your provider network that you now have to manage. And in some cases, you have to deal with duplicate MAC addresses. You get these networks so large that there is possibility that you can start seeing duplicate MAC addresses, and you have to deal with, you know, the logs and the errors that are going to be thrown at your NOC and working around that. And there's nothing really you can do about it other than just kind of ignoring it or working with the vendor to try and come up with a solution so that it doesn't become a global problem. So spanning tree has always been a big issue. I've never liked it in the carrier environment at all, delivering services out to the edge. It's a real hassle to deal with. It's so slow. The convergence time on spanning tree is extremely low, and they've come up with the Layer 2 control protocols to help try and separate the Layer 2 protocols like CDP and BPDUs and all these other things that are going to broadcast on a Layer 2 network. And without those things in there, they can really play havoc with your network. Even if someone doesn't know a tech and they're not familiar with that and they take it off briefly just to put it back on or to make a change to it, it can then introduce BPDUs into your network, and you can introduce BPDUs into their network, which will put ports into an error disable state. It'll break things. It's one of those caveats that you really have to know what you're doing when you're getting into these networks. I think I skipped a slide here maybe. Nope. So within the last 5 years that I've been doing this, it's been quite interesting. There's been a lot of progress with Ethernet service. Q&Q came about, Ethernet ring protection with sub 50 millisecond restoration. That really helps when you start doing rings and you want to move away from spanning tree. It is extremely quick, and sometimes you don't even notice a packet drop. There's Ethernet timing now. The IEEE 1588 and the ITU-T 8262 for doing TDM over Ethernet, SONET over Ethernet. You need that timing available to support those types of applications. The SLA support now with Y1731 for monitoring links and latency and jitter and packet drops. That's been wonderful to have into these networks to start really getting a look at how the circuits are performing. And also OAM, loopbacks, dying gas, link monitoring, all those things have been great now that they've been integrated into the equipment, and it's been rolling out in the last couple of years. It seems like vendors are starting to realize that, you know, some of these rural carriers don't have an ability to, you know, roll a truck out into the middle of nowhere to get to a government building on a reservation. And it makes it real simple where you can just loop back something up, test the circuit all the way through, and, you know, call it good. Same thing with dying gasp. That's been wonderful as well, where the box loses power, it sends a message to our NOC, and they know exactly what's wrong with the box. They know it lost power. It's not a fiber cut. It's not something that went down in our head end. It was strictly at the edge, and this is what happened. The link monitoring has been very cool as well, where if you set it up properly with the proper domains and everything, you can actually share that domain with another carrier, and between the two different carriers, you can see how the networks are performing, and you can get notifications, you can see end-to-end visibility, you can add Y1731 on top and shoot it from your network into another carrier network. But it does take a lot of work, and it's very time-consuming, and everyone really has to know what they're doing when they're setting that stuff up. So this is kind of what I'm predicting, looking out ahead. I've been involved in a lot of the data center stuff going on here, and I see a lot of the data center technology eventually filtering over into the metro technology. The data center is very connection oriented, and it is built to handle, thousands of MAC addresses, and they've got the PBB, the provider backbone bridging. That tech is currently in the data center. That's very limited deployment in the metro right now. It's being very limited use. Right now, the only use that I've been seeing it used in is just for layer 2 control protocols and handling those BPDUs, which it does very well. There is no spanning tree in the data center. Everything is, shortest path bridging, trill, fabric path, Q-fabric. There's kind of a debate right now as to where that's all going to go. Hopefully that the standard will come about, and a lot of people will jump on the standard, and we'll see what happens, and could be some great things that can filter out from that. The data center bridging, I think of this kind of as a QoS when it comes to data centers. It adds all kinds of reliability into the network. You get congestion notification, priority-based flow controls, discovery and exchange protocols, so it really adds intelligence and QoS to the network. And I really, really see a lot of this stuff that could be moving into the metro market and making the metro market